So let me explain in simple terms why this technology in this form is dead on arrival.
Yeah.
The mRNA platform takes a message, a transcript of a gene, and it imports it. It imports it into the body in lipid nanoparticle. Lipid just means fat, and fats are absorbed by other fats. Your cells are all covered in fat. So we were initially told that the vaccines stayed in the site of injection.
Right.
Obviously, that wasn't going to be
Right
true,
here.
and it turned out
Yep.
not to be true.
Yeah.
Which means that they're going to circulate around the body in the blood and the lymph. Where will they get taken up? They will get taken up arbitrarily around the body, wherever the lipid nanoparticle bumps into a cell and the fats merge and this transcript is injected into the cytoplasm of the cell. When the cell takes that transcript and it translates it into protein, the ribosome picks up the mRNA and it reads it. Now, there's a lot of flaws there. The way we've stabilized these molecules makes the ribosome prone to produce garbage on the other end, which is dangerous. But even if it worked flawlessly.
If it does, if it's a perfect copy and really like just delivers exactly what the recipe said to make.
If it did exactly what the brochure said,
Yeah.
it would still be deadly dangerous. And the reason is that the immune system, one of the things I learned in that immunobiology course all those years ago, was that the immune system has an incredibly elegant mechanism for distinguishing self from non-self. Your immune system is composed of a huge number of cells. They can react in principle to any biological molecule that they encounter. But early in life, in utero, in fact, there is a sorting process where all of the cells, you have this huge array of cells that react to different things, all of the cells that are triggered in utero must be reacting to you because you're the only thing present, right? You're insulated from the world.
Mm-hmm.
So the immune system turns off all those lineages that are reactive in
Everything
utero.
I'm seeing right now is me.
Is me.
Don't attack it.
Those things are on the white list, right? Everything else is foreign. So when you're born, the point is all of the cells that would react to you are already turned off, and anything that your immune system sees is now foreign, which doesn't make everything a pathogen, but it means those things are not self. So a self, non-self recognition system is the core of a properly functioning immune system. When you get sick with a virus gets into your body, it invades a cell, and it hijacks it. That cell now starts producing virus, and that cell will burst open, it will spill over to the next adjacent cell, and eventually some tissue will start leaking virus. You'll cough it onto somebody, they'll start producing virus themselves. So the immune system looks for a hallmark of viral infection in order to cure this. The hallmark is a cell that is making self-antigens and a cell that is making foreign antigens. Anytime the immune system sees a cell making both self and foreign, that is a virally infected cell. And the one and only right thing to do is to destroy it.
Kill it.
Yeah. So if that happens in your arm, in your liver, the surface of your lungs, it's not positive. It's a loss of tissue, but it's a manageable loss.
Right.
If that happens in your heart, it's a disaster, especially if it's a bunch of cells, because your heart, for reasons that actually go back to that telomere story that we talked about up top, your heart has almost no capacity to repair. What it does instead is it scars over, and scar tissue is not the equivalent of the tissue that was replaced.
Especially not something that's got to be flexible and moving.
Right. It can't, can't fail for 80 years of continuous pumping. So these shots, by their very nature, if they work exactly as the manufacturer suggests, cause your own tissues to be attacked by your own immune system.
It makes your cells make self and foreign proteins at the same time.
Yep.
Therefore, relaying the immune system, attack and kill this. It's doing that. If it lands in your heart cells start doing that. We are attacking and killing. That part of the body does not regenerate cells, causes scarring.
Right.
Thus, we have this issue of myocarditis, pericarditis.
And this is very rarely, your immune system attacking your own heart cells is very rarely necessary. And the reason is the heart is not a good place for a virus to land and try to spread to anybody else. So it's not a target, it's well insulated. So in the case that your immune system detects a virus in your heart, that's a very serious situation. And destroying heart cells is not something that selection would program us to do haphazardly.
Right.
It's a dire choice to have to make. So my point is, I don't care what antigen you load into this thing. You're going to get the cells of the body taking it up arbitrarily. You're going to get cytotoxic T cells attacking the locations of translation of these proteins, and that is going to cause wounds, which in the case of the heart will then become scars. You have an absolutely acute pathology. If you get a bunch of heart tissue damaged simultaneously, like if, as John Campbell pointed out in one of his early videos, the failure to aspirate the needle means that you potentially might, hit a vein and get a whole glob of this stuff floating around the body. If that lands in your heart, gets absorbed, you get a bunch of heart tissue that's producing this foreign antigen, immune system comes in, kills that tissue. Now you've got a wound in your heart. And I must say I'm concerned when we say myocarditis. Myocarditis means inflammation of the heart tissue. It's not a pathology, it's a symptom. Okay? What is it a symptom of? Heart damage, destruction of heart tissue. That destruction of heart tissue is a critical problem. If you've got a significant number of cells that have been destroyed, you've got a wound in your heart. Let's say you're a soccer player. You don't know that there's some portion of your heart wall, the aorta has a weak spot in it now that wasn't there 2 weeks before, and you're running for the goal and your blood pressure goes up beyond what it's done, and boom, suddenly it blows a hole in the wall, right?
Yeah.
You don't know that that's there. But even after it heals over time, it becomes a scar, you're compromised for life.
Yes.
So there's no way that we should be risking triggering our own immune systems to attack our own tissues arbitrarily, which is what these shots will do, irrespective of what the antigen in them is.
Yeah.
So the attempt to blame the spike protein, of course, suggests, yes, we made a tragic error. The spike protein.
Focus on that.
Right. Focus
Next time we won't do the spike, but we love this mRNA technology.
Right.
We're moving forward.
And of course, they love the mRNA technology because A, it's cheap to produce. I mean, basically, you can produce a new vaccine by typing a sequence into a computer.
Yeah.
Right? B, it allows them to take a bunch of shots that, are arduous to produce and streamline their production, so it's economically tremendously efficient. C, you can produce shots for a whole bunch of new things without having to come up with some new protocol for producing them because it's all the same. D, you can tell the FDA, well, this is the same shot you've already authorized, so we're just going to...
It's already been proven to be
It's already been proven.
Same technology.
Yeah, we'll just test the antigen this time, see if the antigen causes any special problems. So your control group and your treatment group are both going to have the pathologies of the mRNA platform. They're going to disappear because you get the same amount of pathology in both groups.
Yeah.
So anyway, it's a dream come true for the ruthless bastards in pharma.
Right.
It's a nightmare from the point of view of patients.
Yes.
Absolute nightmare.